Hey students, I'm going to be going over box and whisker plots today, also known as the 5-number summary. So the learning targets for today are determining the 5-number summary of a data set, including interquartile ranges, and we'll use these value points to create a box and whisker plot. And so I'll have you assess yourself on these learning targets at this time. So previously, we talked about how histograms are one way to show how data is distributed. Well, box and whisker plots are just another way to show that distribution. This is what a box and whisker plot could look like. Obviously, it has a box in the middle, and literally these lines on the sides represent what we would call whiskers. And I'll talk more about how this can show how our data is distributed. Each of these points on the box and whisker plot is specific to your data set. Notice how we have this number line at the bottom here. And the lowest point, or the far left of the whisker, is at around 20. Then we have the left-hand side of this box that might be at 29 or so. Then we have the middle of the box at 60-something, the right-hand side of the box, and then the very far right of the whisker is all the way up at 90-something there. And what these 5 points represent, at least in our curriculum, is what they call the 5-number summary. And I'm going to go through how to calculate all 5 of these values from a data set. But I wanted to show you just kind of an overview in this diagram what each of those represents. So we have a data set here, and the question is, what is the 5-number summary of this data? Note that the data does need to be in order to do these calculations. You might have noticed that one of the things we're calculating is the median, and from previous videos I talked about how it's easiest to find the median if you have your numbers in order. And so these ones are already in order just out of convenience. And I would recommend finding your 5-number summary in the order that I have it listed on the left-hand side here. And so the first thing that you're going to want to find is the minimum. So the minimum, or the min as I have it written, is the smallest number in your data set. And so the smallest number is 8 in this case, smallest number. And then the next one that is the easiest to see in your data set is the maximum, or the highest number, which is going to be 49. And then next we're going to go through to find the median itself. Okay, so to find the median, that is the middle number of your data set. So I'm going to go ahead and start crossing off the numbers on the end to find what's in the middle. So I've got 1 and 1, 2 and 2, 3 and 3, 4 and 4, and then the middle one is the 20. I kind of do that one by one thing just in case there might be 2 numbers in the middle, in which case you need to find the average of those 2. But 20 is going to be our median, the number in the middle, so that's 20. And then the next 2 values that we're going to calculate is actually related to the numbers that are to the left of the median and the numbers that are to the right of it. So your lower quartile is what I like to call your lower median. So excluding your actual median, which was 20, we're going to find the median of the lower numbers on the left-hand side here. We clearly have 4 options there, and so there's not a specific middle number since there's an even amount. It's definitely not going to be 8 or 17, but we need to find the number that is halfway between 10 and 12, and that's going to be our, what we call the lower quartile, or the lower median. And so halfway between 10 and 12 is 11. And so that's going to be our lower median. And of course, if you need to calculate that, you can just find the average of 10 and 12 by adding them together and dividing by 2. And then your upper quartile is basically the median of all of the values that are higher than your median, your true median of 20. And so all of my higher numbers, there's also 4 of them. So I don't have a true median of those 4 numbers. I'm going to have to find the average of 30 and 40, or excuse me, 30 and 34. You can kind of do that in your head too. The number that's halfway between 30 and 34 is going to be 32, or you can calculate the average of that by adding those two together and dividing by 2. And so I want to talk about what these cues represent here. You may be able to tell that if we kind of do these in order, starting with Q1, that is my lower quartile. This is also called quartile 1. That's what that Q stands for. The 20 represents our quartile 2 as it's written. Quartile 2. And lastly, we have quartile 3, which is the upper quartile. And so really what's going on here is we're taking our data set that we have, and if we were to split it into 4 different chunks, kind of like so, more or less, basically splitting it into fourth, that's where that quartile kind of comes in. The first quartile is going to be at 11, the second at 20, and the third at 32. So we are going to use all 5 of those points to help us draw our box and whisker plot. So I'm going to start off by just labeling each of the 5 points onto my number line. So if you remember, our minimum was at 8, so that is going to be the lowest value on our box and whisker plot. That's where that 8 is going to go. The next value is at 11. That is our first quartile. That's actually going to be the left side of our box, but I'll draw that later. The 20 was our second quartile, or our true median, and that will be a little line in the middle of the box. 32, the third quartile, is going to be the right-hand side of the box. And then we also we calculated the maximum earlier too to be all the way up here at 49. And so I'm going to go ahead and start by drawing my box freehand the best that I can. Luckily on your unit test, you won't have to do any of this freehand. It'll actually just be multiple choice options for you to select from. So the left-hand side of my box is at 11, the right-hand side is at 32. So the box kind of encompasses all of our quartile numbers. And then there's a little line where that 20 should go, the middle quartile. And then we're going to make our whiskers extend all the way out to the lowest value on the left-hand side, and then the maximum on the right-hand side, all the way up to 49. And so what does this box and whisker plot really tell us about our data? Well, it's telling us that the majority of our points or our values are kind of more squished onto the left-hand side. And we might have what is called an outlier point all the way out here at 49, but the majority of our data can be visualized over here, which is a little hard to do when you have just a set of numbers to look at and not some way to visualize it. But this is pretty much it for a box and whisker plot. So to summarize, we determined the 5-number summary of a data set, including the interquartile ranges. And then we also used those values to create a box and whisker plot. I'll have you reassess yourself on those learning targets for today, and I'll see you next time.